Welcome, everyone. Today we're excited to present our latest project, a hybrid BCI-based exoskeleton arm designed to revolutionize the rehabilitation process for patients suffering from post-stroke disabilities. A stroke is a devastating condition that occurs due to disruptions in the blood supply to the brain. This can cause serious issues such as brain tissue death, leading to disabilities, particularly in the upper limbs. As a result, we are motivated to find a solution that can help these patients recover as quickly as possible. Did you know that stroke affects millions of people worldwide, with over 15 million new cases reported each year? This is a staggering number, and we must take action to address it. In the MENA region alone, a 2019 study showed that 1,826.2 people per 100,000 suffer from disability-adjusted life years. This number represents the loss of 1 year of full health. This is where our project comes in. By implementing a brain-computer interface system and using an exoskeleton arm, we aim to enhance the rehabilitation process for patients suffering from post-stroke disabilities. Our project has the potential to make a significant impact on the lives of millions, narrowing the scope of disability and giving hope to those who need it the most.
Taking into consideration that EEG signals are recorded from brain and EMG signals are recorded from muscles. Now getting into the system architecture. In our project, hybrid EEG-EMG brain-computer interface technology is going to be applied for developing a rehabilitation exoskeleton for stroke patients. To achieve hybrid BCI system application, the following phases are going to be implemented. For signal acquisition phase, EEG signals are going to be captured by EEG headset and muscle signals are going to be detected by an EMG my arm band. These signals will be amplified for easy detection. For pre-processing phase, both EEG and EMG signals will be fed to the NVIDIA Jetson Nano microcontroller unit as input signals. The machine learning algorithms using Python are uploaded on NVIDIA Jetson Nano. These algorithms will be responsible for reading the data of EEG signals, signal filtering, in which bandpass filter will be applied with low frequency of 8 Hz and high frequency of 12 Hz. These filtered signals are going to be sampled at regular intervals using an analog to digital converter. The digital values are quantized to a specific bit depth and resolution, which determines the accuracy and precision of the digital signal. For signal processing phase, digital signals are then processed using algorithms to extract features like linear regression algorithm and then classify them into specific brain states. The output of the algorithm will be commands that control the motions of the exoskeleton arm for rehabilitation.
Exoskeleton arms are already available on our market, but our project aims to differentiate itself by using a hybrid BCI-based approach to make our exoskeleton arm more affordable and reliable for stroke rehabilitation. By incorporating brain-computer interface into our design, stroke patient can achieve a more intuitive and natural control experience. We have created a detailed project plan that identify the critical paths and milestones for the project and ensure that we will meet the deadline. Additionally, we have made sure that all components of the project are in the market are available.
I will be presenting our design for an exoskeleton arm. The first phase of our design focuses on the exoskeleton forearm. We consider two important factors, weight and adjustability. To make the exoskeleton lightweight, we chose to use 6PLA nylon material, which has a density of 1.15 gram per centimeter cube, which is relatively low compared to some other materials. The exoskeleton forearm is designed to fix the wrist, forearm, and upper arm with straps on the base. The base is specifically designed to hold the patient's forearm, motor mount, motor hub, and other links. We made sure that the patient's elbow joint is concentric to the motor shaft to reduce stress on the motor by aligning the motor shaft with the center of the joint, as we improved accuracy and precision and allowing better control and movement in the desired direction. Additionally, the elbow joint is equipped with a sensor that detects the arm's position and relays that information to the control system. The second consideration we focused on was adjustability. We designed an innovative aspect to our exoskeleton arm that allows for adjustable length based on the patient's arm length and size. We discovered that the length of the forearm typically falls within 25 cm to 35 cm, so we designed the exoskeleton arm to be 25 cm when it is closed and 35 cm when it is extended.
And now let's dive into the social impacts that our project brings. Firstly, improve the quality of life for patients. Our system helps patients regain mobility and function in their affected limbs. For example, a stroke patient who previously required assistance with eating or dressing themselves can now do so with the help of the exoskeleton arm. Secondly, increased awareness of the importance of rehabilitation services. The project can change attitudes towards disabilities and rehabilitation. For example, the use of the exoskeleton arm can help reduce stigma surrounding disabilities and shows that people with disabilities can still lead fulfilling and productive lives. Thirdly, better social integration for patients. Improved social integration for stroke patients through our system can lead to better quality of life. For example, a stroke patient who is able to use the exoskeleton arm can perform tasks such as holding a cup or picking up a phone after rehabilitation sessions, which can make them more independent and confident. As a result, they may be more likely to participate in social activities and events such as family gathering or community events, which can improve their mental well-being and overall social integration. And now, I will talk about industrial impacts. Firstly, a spread of BCI technology in our region. This technology has the potential to revolutionize the way we work and interact with machines, making it easier and more efficient to perform complex tasks. Secondly, technological advancement. The project can position our country as a leader in medical technology innovation. This can attract investments and partnerships, leading to further advancements in the field and potential economic benefits. For example, companies and investors may be interested in partnering with our country to develop and commercialize this technology. Thirdly, improved access to health care. The introduction of exoskeleton arm-based BCI technology can improve access to health care for stroke patients and those with other conditions that require rehabilitation services. This can lead to improved health outcomes and reduced healthcare costs. For example, stroke patients who previously had to travel long distances to access rehabilitation services can now receive treatment closer to home. Fourthly, job creation. The development and implementation of exoskeleton arm can create new job opportunities in our country. For example, the manufacturing of the exoskeleton arm can create jobs for engineers, designers, and technicians.